Hello, friends. I know chemistry is a mystery for most of you, and I've decided to help you out to take you to a high grades in chemistry. Now, the first topic that I find most of us finding it difficult is electrolysis. Electrolysis is a process in which we supply electricity to break down ionic compounds. So, the definition which we need to know is the breakdown of a molten and aqueous ionic compound into its ions using electricity. The key terms here are molten or aqueous into its ions using electricity. It is a 3-mark definition which should be learnt by heart. An electrolytic cell is generally made up of an electrolyte, which is molten or aqueous ionic compound, a cathode or an anode. Both of them are made up of graphite because it's inert, or could be any metal which can conduct. How do we remember which is positive and which is negative terminal? The short form for that is panic. Positive is anode, negative is cathode. So positive terminal, positive is anode, negative is cathode. Now, when there is a molten electrolyte, like for example, sodium chloride molten, only sodium and chloride ions are there. So, sodium ions go to the cathode. So, an easier way to remember is cations go to cathode, anions go to anode. Cations will gain an electron, hence it becomes reduced to a metal. And an anion loses electrons, hence it's getting oxidized to a element. Now here chloride becomes chlorine. There are certain more examples that could be taken, and it's easier to remember oxidation at cathode and reduction at anode, or oil rig. Oxidation is loss of electrons, reduction is gain of electrons. Another example that we could take is lead chloride. Since it's molten, lead being a cation goes to the cathode. Chloride being an anion goes to the anode and forms chlorine gas. Now they could ask you, what is the test for chlorine gas? The test would be that the litmus paper gets bleached. They could also ask you, what would be your observation? So when there is a gas, the first observation is bubbles, but because it's a halogen, chlorine, which is a colored gas, so the observation will be bubbles with a yellow-green color. Copper sulfide molten would give copper at cathode and sulfur at anode. In this case, there is no gas, so there will be no bubbles. I hope that is clear. Moving to aqueous solutions. Now this is an important one and asked at examinations more often. They say if copper, silver, gold, platinum are there in the aqueous solution, then they go to cathode. Otherwise, hydrogen goes. Now, aqueous means any compound dissolved in water. Hence, water is also present. So, when an electrolysis takes place, the compound ionizes and water also ionizes. Water forms hydrogen ion and hydroxide ion. So, this hydrogen comes from the hydrogen ion of water. If there are halides as an anion, then they would go to the anode, else hydroxide goes. Now here there is a little catch. If it's a concentrated solution, then the halides go. But in case the solution was dilute, then hydroxide would go. Hydroxide equation is generally difficult to remember. I suggest practice it 4-5 times. 4 hydroxide ions gives you water, oxygen and electrons. 4 electrons. Now here the observation would be bubbles But since oxygen is a colorless gas, you cannot write oxygen is seen. You have to write glowing splint relights. For hydrogen, you would say bubbles observed and a lighted splinter goes off with a pop sound. Let's look at some mixed examples. You may answer along with me. So molten lead chloride, cathode, lead, anode, chlorine. Nothing remains behind because it's molten. There's nothing else. Dilute NaCl, sodium goes to the cathode, chlorine goes to anode. Am I correct or am I wrong? Think. Yes, I'm not correct. Sodium is not in the list of those noble metals. So when it is a dilute solution, instead of sodium, hydrogen goes to the cathode, and because it's dilute, chlorine doesn't go, hydroxide goes to the anode, hence oxygen gas is formed. Now since hydrogen and hydroxide both from the water are removed, water becomes less and less in the solution. Hence, instead of dilute, the solution becomes concentrated and remains behind. So what remains behind in this case is concentrated sodium chloride. Similarly, you could do for aqueous copper sulfate, where copper and oxygen will be formed at cathode and anode. And what will be remain behind would be hydrogen from water and sulfate from here. So it would be hydrogen sulfate or it would be sulfuric acid. Dilute KOH or potassium hydroxide would give hydrogen at cathode and it would give hydroxide at anode. And again what will remain behind would be potassium hydroxide only, but in case of dilute, it will become concentrated. The last example in this table, molten potassium iodide. There is no water, so it's simple. Potassium goes to cathode, iodine goes to anode, nothing remains behind. So what it means is that for molten, nothing remains behind, whereas for aqueous or dilute, there are two ions, a cation and an anion, which would remain behind. I hope this concept is clear. We move on to the next part, the applications of electrolysis. Again, very important at the examination. First application is electroplating. Now, in case I have an iron vessel, a jug or a glass or a spoon, it gets rusted easily. So it's always advisable to electroplate it with another metal, generally silver or copper. Copper is a noble metal, so we use copper in this case. We connect the article, in this case it's a metallic spoon that has to be electroplated to the negative terminal, the cathode. And the anode or the positive terminal would be a pure copper electrode. As soon as you switch on the circuit, copper would deionize and get inside the solution. The solution here could be any copper solution. In this case, it is copper sulfate. The copper ions will move through the solution, electrolyte, and get deposited over the spoon. So at anode, copper ionizes and gives away 2 electrons, hence oxidizes. At cathode, the electrons are accepted by copper and forms copper metal. The thing to note is that only that much part of the spoon will be covered with copper, the part that is dipped inside the solution. Why? Because there's no current being passed, the copper is not reaching at the tip of the spoon. So in case I want the whole spoon to be covered, it should be dipped completely inside the electrolyte. Here, the electrolyte is not participating in the electrolysis directly. It is only helping the ions to move. Electroplating helps to resist rusting or corrosion of a metal, and it also makes the article look attractive or beautiful. The second application is extraction of aluminium from bauxite. Aluminium is the most abundant element used worldwide. Why? Because aluminium always has an oxide layer, hence it is safe to be used for packaged food. The packaged food or the food delivered by Zomato is generally given in an aluminium foil. Aluminium is found in the Earth's crust in the form of an ore called bauxite. Bauxite is chemically aluminium oxide, but there are a lot of impurities in it. So to remove the impurities, we scrub it with NaOH. Sodium hydroxide, which is a base, is actually like a soap. It removes impurities. Now just a quick reminder, aluminium oxide is an amphoteric oxide, since it behaves like an acid also and a base also. It reacts with an acid to form a salt, reacts with a base to form a salt. In this case, it's reacting with a base to form a salt, and that is the reason it remains dissolved in the electrolyte. Whereas impurities like iron do not react with NaOH and are filtered off. Now this clean, fresh ore is called alumina. However, chemically it's still aluminium oxide. This melts at a very high temperature of 2030 degrees. To bring it down and to save on fuel and the cost, we add something called as a cryolite, which is another ore of aluminium but has very little aluminium in it. This cryolite not only increases the conductivity of the solution but also reduces the melting point to 950 degrees. Now we are all set with the molten alumina to electrolyze it. Here the cathode is a steel vessel and the anode is graphite rods. Graphite, which is carbon, reacts with the oxygen that is formed at it, and hence it gets depleted because carbon dioxide is escaping in the air. Besides carbon dioxide, we also get oxygen and fluorine at the anode. That's fluorine comes from the cryolite, and oxygen and carbon dioxide and carbon monoxide come from the oxygen. Our molten aluminium deposits at the cathode, which can be used, further refined, and then made into alloys. I think that is all that I have for today. Just a brief introduction of mine. I am Alka Chaturvedi. I have been teaching chemistry for a long time to MYPs, IGCSEs, and the state boards. So, signing off today, this is Alka Chemistry Series 1, waiting to release the next one. Thank you.